Hi students, Dr. C here. This is our Chapter 4 lecture on carbohydrates, and we're going to talk about the myths behind carbohydrates. We're going to talk about the different types of carbohydrates, what they can do for the body, the acceptable range or intake for carbohydrates, and then we'll get into diabetes, alternative sweeteners, and the importance of fiber, which is also considered a carbohydrate. So what are carbohydrates, right? And why do we need them? Well, we talked a bit about whole foods, right? Veggies, fruits, and nuts, whole grains, and beans, and seeds. These are all largely carbohydrate-containing foods, okay? They contain a little bit of everything, but in very small amounts. They're mainly carbohydrates. And these are staples, if you think about it. These are really important to a lot of cultures around the world. If you think of African cultures who have survived on, root vegetables and grains and so forth, and rice and legumes. If you think of Latin American cultures that have also subsisted on rice and beans. Our Native Americans, corn, beans, and squash. There have been many healthy populations throughout the world who have a largely plant-based diet. And if you look at the Mediterranean diet as well, it's very, very plant-based with much smaller proportions of seafood and animal meats. And then glucose is sort of the basic element, right? The basic unit, okay, of carbohydrate. And this is important because it's the first line of energy for our brain, and it has to accompany red blood cells on their journey to take oxygen throughout our body, including to our brain and our muscles and our heart and everywhere else, right? And so glucose is sort of the main source of fuel that our body will rely on for energy and to carry out its normal functions. And let's think back to, I don't know, maybe it's 8th grade or 7th grade biology, right? C6H12O6, right? Photosynthesis. So plants, first of all, plants are growing for their own good, right? A plant exists in nature as part of a food chain, okay? But the plant's real purpose, right? If we could ask a plant, what's your purpose? We assume that it's to grow itself, right? And to stay healthy and strong and survive until it doesn't survive, right? So what plants do is they grow and they convert. The way they survive is they convert the sun's energy into glucose through a process called photosynthesis. Now, they have pigmentation, right, in their leaves, which we call chlorophyll. That's why they're green, right? And they absorb carbon dioxide and sunlight, and they turn this into glucose. They also add to that sunlight and CO2 minerals from the soil and water from the soil. And what we get is glucose, which is what plants are made of, as well as other things such as some protein, some fat, some vitamins and minerals. When you bite into, as I've told you, a seed, okay, you're getting an outer layer of fiber, right, or bran. You're getting an endosperm, which is the second layer inside, which is mainly starch. And then you're getting the centermost part, the endosperm, which is composed of vitamin K, some other vitamins, and also, some unsaturated fats, okay? And so, there's a little bit of everything in a plant, but mainly glucose. Now, glucose is made of, glucose units often link with other, here's a picture of the photosynthesis for you. See CO2 coming in, sunlight coming in, water and vitamins and minerals coming in through the soil, and the byproducts are oxygen and glucose, and that's our glucose molecule. Oxygen, remember, plants are awesome, and this is why we worry about cutting down the rainforest, right? It's because we have a lot of carbon dioxide in our air due to emissions, right? Car emissions and pollution. And plants really recycle this and turn it into oxygen and send it back into the atmosphere. And that's why we want to keep our rainforests, right? We want to keep our oceans clean and healthy because algae do the same thing for us. We need oxygen in the air and less carbon dioxide. So the fewer plants we have, the more pollution we're going to have, okay? So why do you need these carbohydrates again, right? Again, they're the first line of energy in our bodies. And there are a few types of these. So our simple carbohydrates are these. We call monosaccharides because it's one simple sugar, mono, okay? Glucose, which I just demonstrated to you what that looks like and where that comes from. fructose, which is a sugar that that a plant has, okay? And this is another unit of sugar. It's sweeter actually than glucose, but it is another sugar that's found in plants. And galactose, which is a little bit different than either of these molecules, and is also, well, it's actually part of the milk sugar, the sugar that you taste in milk. And then we have disaccharides, saccharides. These are two of these monosaccharides put together. So if you take one glucose and another glucose molecule, you get maltose. And you guys, most of you probably won't remember, but there used to be a drink called malted milk. And it was maltose, basically, on top of ice cream. And this was a really, really powerfully sweet and nutty, crunchy flavor. So that's maltose. Glucose plus fructose, okay, so a regular a plant sugar plus a sweeter plant sugar equals sucrose. And this is what our table sugar is. If you go to the sugar bowl and put a scoop of sugar in your coffee, you are having table sugar, sucrose. And then milk sugar is glucose plus this galactose. That equals lactose, and that's the milk sugar that many people have a hard time digesting or lack an enzyme, lactase, to digest that milk sugar. Now we have polysaccharides, okay? Poly, think many, okay? So these are the long chains of sugars that are linked. And these compose our starches, fibers, and glycogen. So think of all those little single sugar molecules put together in groups of two as disaccharides, so monosaccharides to disaccharides to polysaccharides. This is where we get our more complex carbohydrates, okay? Starch is the storage form in plants, okay? So plants make this glucose, but when they don't need any more glucose for growing, they have more than they need, they store the extra glucose as starch. And in plants, we call this amylose, okay, which are straight chains of glucose, or amylopectin, which is a more branched form of this, okay? But what I want you to really focus on is that polysaccharides are more complex chains, okay, of sugars linked together, and starch is the storage form in plants. This is just a handy diagram of our monosaccharides, glucose, fructose, and galactose, and then two and two linked together, table sugar, okay, milk sugar, lactose, and maltose, which is malt sugar. And then the polysaccharides, as you can see, are big long chains of these mono and disaccharides, amylose and amylopectin, and these are the storage form of glucose in plants. Polysaccharides, they wind these big long chains of sugar, and they store these within them, okay? And when we eat a starchy vegetable, this is what we're eating. We're eating this stored and complex form of sugar. So fiber, again, is another type of polysaccharide or storage form, okay? But this is non-digestible. And here's some forms you may hear about, cellulose, lignans, gums, pectin, okay? This passes through our digestive system largely undigested, but again, it helps us to push waste throughout our body. The reason we don't digest it is because we don't have an enzyme devoted to it, but it certainly has, again, the function of pushing things through our body and also acting to absorb things like cholesterol and drive it out of the body. Okay, and when we look at a label and we look at total fiber, we're looking at the total dietary fiber plus any functional fiber that's added. And as we'll learn, sometimes in things like yogurts, in soups, and other types of foods, we add some additional fiber. So when you see foods that say added, fiber added, okay, for example, in say Activia yogurt, they add some functional fiber in there. I don't know whether it's chicory root or something else, but that's meant to add fiber to help that be a higher fiber food in order to help you with digestion and elimination of waste. Now, fiber can get a little tricky, and even when I was studying fiber, I would always get confused between these two. So there's two types of fiber, and they're classified by their affinity for water. Now, what that basically means is one's going to absorb water, which is soluble fiber. Okay, think about soluble. This is like a sponge. Okay, think soluble, sponge. This soaks up and latches to, okay, dissolves in water, and it can cling onto things that are harmful in the body to drive them out, like cholesterol, right? Think of it as like a viscous fluid, right? It's like a thickener, okay, because it does absorb water like a sponge. And this goes really slowly through our digestive tract. And you may see it on a label, again, referred to as pectin in fruits and vegetables. If you look at jelly, sometimes even in jams, we add pectin to jelly to make it that kind of gelatinous substance, right? Without it, it would just be kind of a bunch of fruit, right? Beta glucan, which is what we find in oatmeal and barley and some of these other grains that absorb, and we know that are good for lowering cholesterol. Why? Because they absorb stuff and they drive it out of the body. And then our insoluble fiber. Think, this does not dissolve in water, okay? Insoluble. It's also indigestible, okay? So insoluble. These are our hard fibers that are not going to dissolve in water, okay? They go fast through the digestive tract because they're not hanging out there absorbing things and then going. So they go fast. They may have a laxative effect, right? If we eat too much, for example, if you eat too much, let's say, too much whole grain bread, or if your body's not used to it, or too many beans, you may find yourself running to the bathroom, okay? Examples of these are whole grain seeds, fruits which contain seeds, say pumpkin seeds, anything that has its bran layer intact, and sometimes vegetables, right? If you eat too many vegetables that are really roughage, right, and your body isn't used to it, and they contain insoluble fiber, you may find yourself running for the bathroom as well. So anytime you go to switch from a diet that's lower in fiber to a diet that's higher in fiber, you want to take your time and let your body adjust. So most plant foods contain both soluble and insoluble fibers. An example of those are beans. And again, that's because the outer skin of the bean is more like a bran layer and it's insoluble, whereas the inside, the starchy part of the bean, is soluble. Now, glycogen is our form of starch. Okay, we're holding glycogen, which is branched glucose, which is glucose we eat above and beyond our needs to keep our body going in our body for quick energy. Okay, so for example, let's say we have a meal. Okay, we have a meal. Our body processes the glucose that we need to fuel our brain, our muscles, our neurological system, and all our body's functions, okay? It takes a certain portion of that glycogen and turns it into this branched storage form that is stored in our muscles, okay, for ready energy, and stored in our liver in case we need it. It's there just in case we need a quick burst of energy, or if, for example, if we're going to work out, right? So as you may have heard, we're going along during the day, we're burning glucose and we're burning other fuels, but mainly glucose. And then glycogen, when we need it, let's say we go to work out, all of a sudden we start burning more fuel than our body is used to, and so we tap into this glycogen. And that's why when the end of this glycogen this glycogen is used up, that's when we start to get tired, right? And we start to tap into other energy. And so glycogen is there for our flight or fight response, or any stress on the body, even positive stress like exercise. Okay, we only have limited amounts, right? So we're animals, all right, and other animals also store glycogen, right? But when an animal dies, this stuff breaks down, okay? So when we eat an animal, we're not really eating that starch or storage form of glucose that the animal would be using, right? So if we're eating meat, we're really not eating the stored forms of that. It breaks down, and so we don't get they're not accessible to us through the diet. And that's why when we have meat, we don't think of it as a starch. It's not starch containing. So I'm going to go through the process here of digestion. And this might be a little repetitive, but I think that it's a good, our book kind of goes through different ways of explaining it. I'll try to explain it the best I can, and we can skip over things that might be too repetitive, okay? So first of all, digestion of carbohydrates begins in the mouth, okay, and goes on into our intestines. Our saliva is actually the first enzyme, okay, that starch comes into contact with. That's called amylase. And it starts breaking down amylose, okay, a sugar that we get from food, and amylopectin into smaller starch units, okay, and maltose. So we start our food breakdown in the mouth. And then in the small intestine, our pancreas is always secreting amylase that breaks down remaining starch, okay, into maltose. And as you can see, we're building, we built up from a glucose molecule, right, to a maltose or, so forth molecule. And now we're building down, we're breaking down, okay? So now we're taking maltose and other disaccharides, and we're breaking them down to monosaccharides, which can then be absorbed into the blood. Now the fiber continues to the large intestine, where some is broken down and feeds our gut bacteria, okay, in our colon, and most of it is eliminated in your stool. Other of our fiber, right, our soluble fiber, is absorbing water and is pulling things like cholesterol out of the body. This is just another diagram that shows you the digestive system, the different organs of our GI tract, our gastrointestinal tract, beginning with our mouth, and it gives you the molecules broken down there and the enzyme. And also we have a mechanical breakdown there, right? As we chew, we start to break down food. And, even with when we start to get hungry and our mouth starts to water, that's amylase, right? Kind of being secreted because we're ready for a meal. We're getting ready to start breaking down that food. And then we have the esophagus, where our food goes down, the stomach, where more enzyme activity starts to come into play, and acid comes into play. And then we have the pancreas aiding by secreting more amylase to break down food. We have our liver taking up extra glucose and making glycogen. And we have other things coming in from the small intestine. We have other enzymes coming in. And then in our large intestine, there's some final breakdown by bacteria, and then there's elimination. So again, you'll hear people say, I'm lactose intolerant. Now this simply means that, that person might not produce enough lactase, the enzyme to break down lactose, okay, in our body, which is a disaccharide, right? Lactose, okay, milk sugar. And so they may have malabsorption, they may have intolerance, which is, cramps, bloating, diarrhea, gas, and so forth. And so there are pills that people can take with the lactase enzyme, right? I think they're called, Lactaid pills. You can buy milk that is low in lactose or lactose-free in order to still get the benefits of dairy, such as calcium and vitamin D, without consuming the lactose. And this is just, again, some tips for, eat dairy foods with a meal or snack. You can consume the lactase pills, eat smaller amounts. And actually, I have heard that eating yogurt, which is a fermented form of a milk product, a dairy product, can actually be easier on your stomach. Also, then meat and cheese, especially hard cheeses, are much easier on your stomach as well. So, again, we've talked a bit about this, but glucose is our main source of energy for our body, and hormones actually regulate the amount of glucose in our blood at any one time. So think of the pancreas as kind of the regulator for how much glucose is in our blood, ready for our cells to take up, and how many are, between, glucose being in the blood and how much our cells are taking up that glucose, right? So insulin is released by the pancreas, and it regulates glucose in the blood, right? So when we eat a meal, insulin is released by our pancreas, right? Because our pancreas can sense that our blood glucose is going up. And then it takes those, think of it as an unlocker. It's like a locksmith. It helps to unlock cells to let glucose into the cells. And then again, extra glucose becomes glycogen, okay? And that extra glucose can go to the liver for glycogenesis, right? Think of genesis as creation, right? So the liver takes up that extra glucose floating around in the blood and makes it into glycogen, which is our storage form of carbohydrate. And this is just another diagram. I think this is a pretty cool one. Glucose being broken down into sets of 3 carbon compounds, plus energy, plus carbon dioxide, right? And then the last and abundant energy is released from the remnants of glucose, okay? This is really intricate. This is, more than you need to know, but this is kind of the creation of energy in the body. So now when glucose starts to drop in the body and the pancreas can sense this, the pancreas will secrete glucagon, okay? So when sugar levels are high, glucose levels are high, the pancreas secretes insulin, right, to send it through the blood to unlock cells and let that glucose in so it can be used for energy. When that blood sugar is low, when that blood glucose is low, glucagon is secreted to raise blood glucose levels. And that's telling our cells, okay, let's get going. Let's release that glucose from the glycogen in our liver because we need more glucose for our cells in the body, okay? So it signals to the liver to start gluconeogenesis, or making glucose from non-carbohydrate sources. And that's once our glycogen is depleted, the liver's like, okay, I've got this much glycogen. I'm going to send that out. Hopefully this will cover the energy needed. But if not, it's going to start making glucose from other sources, right? And your body then starts to break down its fat stores, right, and send that to the liver, and then we start to make glucose from fat. Now, that's not as efficient of a process as it is from glucose, but our body will then start to break down fat. And that's sort of when people say, okay, well, that's why you should work out on an empty stomach, right? Because you want to start breaking down fat sooner, or, you want to start breaking down fat before you start eating and replenishing the glucose stores. And then epinephrine also stimulates this glycogenolysis, right? Or the breakdown of glycogen. So if you think about epinephrine, this is what gives us that adrenaline shock, right? If we're terrified, or if we know that we have to run like crazy, the fight or flight hormone. This is what causes us to release, to start breaking down that glycogen so that we have that glucose right there in our blood to just take off running or fight or whatever, or run away or whatever we need to do. So here's our food sources of carbohydrates, right? We have veggies, fruits, grains. Protein, as you can see, contains fewer carbohydrates, but some, right? Some carbohydrates. And then dairy contains some carbohydrates as well. And I just wanted to back up to this slide to talk about the quality, the different types. Maybe it was this one. Actually, yes, it was. Wait. Pardon me. Here we go. So carbohydrates, as we said, fuel your body pretty much, right? So when our liver glycogen stores are depleted, which is about after 18 hours or so, okay, we produce what's called ketone bodies, all right? And this is this low carbohydrate diet that many people try to achieve. This is the keto diet, I guess, part of that, and also known as the Atkins diet or the low carb diet, right? And what people are aiming to do is not consume glucose so that the body will break down fat, okay, for energy. And that's all well and good, except that fat can't really be broken down completely, right, to glucose. And so what is produced are ketone bodies, okay? This is what we're talking about, ketone. Now, ketosis means that we have these acidic ketones that come about when we're out of glucose, right? And these can only last so long, too. They can help give us energy for only a certain time. And then we start breaking down protein, okay? So we start breaking down not only just the protein in our diet, but from muscles. And remember, the heart is a muscle. Our organs have muscle, right? And so for people who are on a long-term keto diet, they do risk, we think, some evidence shows that they risk depleting, right, their heart muscle and other organs, the muscle on their body, and even in their visceral organs, because those will be broken down to make glucose out of that muscle. Now, you don't want to be burning muscle, especially not from your major organs, right? And so it's sort of that idea of balance, right? You need a little bit of glucose in your diet, but it should be complex carbs, right, that your body can actually use for energy, because they usually come along with vitamins and minerals. What you do want to avoid are these simple sugars, right, that don't really offer you any vitamins or minerals. They're just energy alone, right, and are digested usually very quickly, and in huge excesses can become fat right away. Whereas complex carbs contain some protein, some fiber, some vitamins and minerals, and so they're digested more slowly. They leave you feeling more satisfied, and they offer all those other wonderful benefits to the body. They're a full package of nutrition, in other words, right? So then, again, ketones are acidic, and some experts also believe that might hurt the renal system, right? Your kidneys, your bladder, and your excretory organs. So, most people need around 130 grams of carbs per day for healthy brain function. Now, this is debatable. Some people may need more than others. Again, it depends on the culture you come from and so forth, but you don't want to go too low on especially your complex carbohydrates. So try to aim for more complex carbohydrates, fewer simple carbohydrates like candies and cookies and sauces and, sugar from the sugar bowl and things like that. And try to, get your carbs from nutrient-dense fruits, vegetables, and then low saturated fat foods, such as low-fat dairy and other lower fat foods. So, what are the best sources of carbs? Again, whole grains help you meet your starch and fiber needs, and they also still contain that endosperm, which has vitamins and minerals and fat soluble fibers. Okay, and they say to aim, if you're looking at bread, you're looking at the nutrition label, and it says look for breads that have at least 2 to 3 grams of fiber. I would argue even 4 to 5 grams would be great, because if you're eating whole grain bread every day, and that's one of your main sources, aim as high as you can. And even in terms of whole grain cereals, I would say upward of 5 grams of fiber is really good for a breakfast cereal, for example. Around that range. Again, you don't have to be absolutely perfectly stuck on the number 5, but let's put it this way: aim as high as you can for fiber, because we don't get it from many other foods in our diet. Fruits and vegetables also provide sugars, starch, and fiber, and they're both very important for the vitamin and mineral content as well. Legumes, nuts, and seeds are also excellent sources of complex carbs, and they also offer unsaturated fats that are heart healthy, and fiber as well. And then again, our low-fat and fat-free dairy can provide good carbohydrate for us. And then, what we want to watch out for are our packaged foods, right? Our chips, our cookies, our pretzels, our sodas, especially anything we drink, right? It contains really highly absorbable sugars that really don't lend us any other nutrients except energy, which can end up, again, when had to excess, can lead to weight gain over time, simply because they go down just so easily, and they start to be absorbed very quickly in our stomachs. So here's our sources of carbohydrates. As you can see, veggies and fruits can provide not only good sources of carbs for energy, but as we said, so many other nutrients that are important. Grains as well, and we want to make at least half our grains whole grains, okay? So grains that still have that bran on them and that are usually brown in color as opposed to bleached white. Protein offers fewer carbs, but there's still some carbs in proteins, like especially beans. And they're very healthy carbs because they contain fiber and starch. Dairy also contains some, and also other valuable nutrients such as calcium and vitamin D. And then our daily needs overall should be around. Carbs should represent anywhere from 45 to 65% of our calories. However, some, as I said, by culture, by different body types and needs and preferences, that isn't necessarily a dead set number. In terms of fiber, the rule of thumb is around 14 grams per 1,000 calories a day. So I find this easier to think of, okay? When you're younger, you need a little more fiber, right? Probably because you're eating more, right, than you do when you're older. Males should aim for around, 38 grams of fiber, and then older males 30. And then for women, 25 and 21. And this is mainly because men eat more food, and women eat a little bit less food. But again, this isn't easy to get. If you think about the kind of diet that we normally eat, let's say a convenience diet, French fries, burgers, hot dogs, chicken nuggets, there's not a lot of fiber in these foods. And so we have to make a conscious effort to the extent that we can, and I know it's a challenge, to get fruits, vegetables, legumes, nuts and seeds, and salads, greens into our diet, so we can make up for that fiber that we're missing. So again, whole grains contain bran, the bran layer, that brown. Think bran, think brown. Okay, it's kind of the husk, right? So bran endosperm, which is the starchy part. It's the main part of the plant, and then the germ, which is that nice little kernel in the middle that has unsaturated fat and our fat-soluble vitamins like vitamin K. Our refined grains, which again are milled to remove that brown, right? As my example was white rice that has had the bran removed, right? And still has some B vitamins, it has some iron, phytochemicals, but mainly it's usually fortified or added back in after the fact, and we don't know if that is as effective, right, or as good for us as the original nutrients that were in the plant. And some examples of refined grains are wheat or white bread. And if you look for bread, look for 100% whole wheat. You may see bread packaged as, quote unquote, honey wheat or wheat bread. Well, look for 100% whole wheat, because that really means that it is an unrefined version of the bread. Okay, and then white rice as well. Enriched grains are grains that have been enriched with some important vitamins. Folic acid is found in many grains, okay, to enrich them, chiefly because we found over the years that folic acid was needed in the diets of many women, in the diets of pregnant women, to avoid birth defects, especially spina bifida, right? Which is a problem with the baby's spine, where they could be born with their spine protruding out of their body, and that, of course, that is very dangerous. And so when we started fortifying grains, we found that I think the percentage was we reduced the incidence of spina bifida for by about 90 or 91, 95%. So it really is effective. Now, what isn't as well studied is the outcome of a lot of fortification, right? As I said, people who are eating energy bars and eating multiple fortified foods every day, we really don't know what the outcomes of those are. Folic acid, I think, is absolutely wonderful, fortified bread and grains, but some of these other nutrients, especially some of these minerals, we really don't know what, eating too much of these is. So you may want to check with the upper limits of some of these various vitamins if you're someone who eats a lot of fortified foods. And then whole grain foods, here's some examples, as we discussed, brown rice, oatmeal, whole oatmeal, right? The best is like that Irish oatmeal that's not milled at all. And then whole wheat bread. And now dark bread, you can get like a dark pumpernickel bread that isn't necessarily whole grain. So again, look for that label that says 100% whole grain bread. And this is just a diagram here to show you, the bran layer, the germ layer, which is the center, and then the starchy layer, okay, which is most of the plants, okay, and it shows you which vitamins and which nutrients are where. And then whole wheat flour is like a browner flour, again. 100% whole wheat flour will be a darker looking flour. It contains the most nutrition. And then there's an enriched wheat flour, which is still bleached, but again, they enriched it back, right, with some of these nutrients. including folic acid, and then wheat flour, which is not enriched, and that is, it still contains some nutrition, mainly just energy, because it's missing all of the nutrients that are contained in regular whole wheat or enriched flour. Here are some good sources of fiber, right? So we can see veggies can provide really good sources. Fruits can also provide great sources. And if we look at, our fiber sources, look, raisin bran, okay, really contains quite a bit of bran. So if you eat a cereal in the morning, you can already amp up your fiber intake with a high fiber-containing cereal. Proteins, depending on what it is, right? Beans, we know, contain plenty of fiber and also so many other great nutrients for us. Peanut butter also contains a little bit of fiber, not a ton, but there are some proteins. Some peanut butters that contain more than others. And the best, I guess, you can do is to get a whole peanut butter spread, right? That contains actual peanuts. That will contain the most fiber, all the way going down to our more refined peanut butters. And then again, our daily needs, and this is just kind of on the median, right? Men need more fiber than women, so shoot, guys, for 38 grams. And you can do this over time. Again, don't amp up if you're not having a lot of fiber at first, don't go all out on one day. But start reading packages and thinking about the fruits and vegetables, especially you eat, and try to add in as much fiber as you can, okay? So another reason to focus on these plant foods, okay? And then ladies, the 25 here, all right? So now processed foods and sweets, right? Why are these bad for you, okay? Well, one myth, sugar doesn't cause hyperactivity in kids. Now, while this may be true, if a child is eating mostly sugar, right, and not getting enough of the other foods that carry nutrition that, kind of make the body healthy overall, I believe the kids who eat too much sugar the main problem is that they are lacking in good nutrition and they don't have enough to supply the brain with the nutrients they need to kind of serve their neurological system well, right? So while it might not be sugar that directly causes hyperactivity, it can contribute to a poor diet, which can then contribute to hyperactivity, okay? We know that too much sugar can also contribute to cavities, right? Tooth cavities. So, any kind of carbohydrate can. So we should be sure to brush your teeth after you eat carbohydrates, especially things like peanut butter that tend to be stickier or candies that tend to be sticky. And especially after sugar-sweetened beverages, because that sugar is there. We know of something called baby bottle tooth decay, right? Where a baby may be sucking on a bottle for hours at a time, and without having their teeth brushed and having that exposure even to that lactose in milk, the milk sugar, and certainly other beverages that I've seen put in baby bottles, which nothing but milk should be put in a baby bottle, by the way. But sometimes people do, and having that contact with the teeth for such a long time can cause cavities. Too much sugar can actually raise your bad cholesterol and triglycerides as well. And since these sugars have empty calories, they may lead to weight gain, and also too much sugar can lead to the risk of diabetes, because what happens is eating all of this sugar over time, okay, eating sugar in excess can, all that sugar, extra energy, can turn to fat, okay? And that fat can gum up our cells in a way that insulin can't get glucose into our cells, okay, to get those cells the energy they need. So what happens? All that glucose still stays in our blood, okay, and goes around in our blood. And again, we can't get it into cells. So what happens? Since the pancreas isn't signaled that all that glucose got into the cells, the pancreas keeps churning out more and more insulin to try to help those poor cells get that glucose into them. And what happens is, over time, the pancreas simply burns out. The beta cells in the pancreas just say, okay, I've had enough. Like, I can't pump anymore. I mean, these cells are all gummed up, and I've done my job. I can't get that glucose into you cells to give you energy. So, you end up with sugar in the blood and none of it in cells. And this is what diabetes is. And it can be very dangerous because your cells need energy, right? And so, and too much blood glucose can lead to things like, wounds that won't heal, right? Because bacteria can feed on the sugar. And that's why you see so many other problems. Also, sugars affecting our nerves, right? So you see people with numbness in their feet and so forth. And our kidneys are strained to filter out the extra glucose in the system in order to, to eliminate liquid waste and so forth. So it really takes a toll on almost all of our body systems. And again, it can cause a variety of these problems, keeping snacking to a minimum so that every time you eat, you aren't exposing your teeth to sugar is important. And drinking water to avoid sugar-sweetened beverages. Like I said, this is my area of research, so I really don't see any reason anyone needs a sugar-sweetened beverage. I mean, once in a while, sure, but water is always the first choice. And then added sugar in foods, we just want to be careful of even natural sugars in terms of giving honey to kids under 1 year because of the risk of botulism. High fructose corn syrup has been used in our country in place of sugar, but basically, it's just using fructose. It's using part glucose, part fructose, and it's just making a sugar or a sweet substance out of corn. Okay, and since we have such an abundance of corn in our country, and farmers who grow corn are subsidized to grow it, we need to do something with this corn. So farmers and scientists found out a way to make a new product. Instead of using sugar, which is more expensive to grow and refine and use, they've come up with high fructose corn syrup, which we think in and of itself, since it is so sweet, can have even worse implications in the body. This is still under study. Finding added sugars on the label can be difficult. Some products now will list added sugars, okay? And as you can see here, this product, this energy bar here, total carbohydrate, 19 grams, 6% of what you would need in a day. The dietary fiber, which is considered part of those carbohydrates, is 1 gram or 3% of your daily value, okay? Total sugars, 7 grams, includes 10 grams of added sugars, okay? And we know that we shouldn't have more than 10% of our calories coming from added sugars a day, okay? So we're already going over our limit here. And if you look down in the ingredients, you can see right up front, granola is the first ingredient, which is whole grain, rolled oats, sugar. It's the second ingredient by weight, okay? So we know that there's a lot of sugar in here. Molasses is also a sugar, albeit a bit more nutritious. You see corn syrup, which is made from corn and highly sweet and may cause more health problems. Again, sugar, corn syrup, high fructose corn syrup, fructose, molasses. So this might be a product you want to think twice about, right? If you look here and you see all the different types of sugar, you may want to go for something that is a lower sugar version of this. So in our diet, where are our added sugars coming from? Again, mostly things like sodas, energy drinks, and sports drinks, just simply because these go down so easily. The sugar is just so easily digested, right? And it doesn't necessarily fill us up because it's liquid. Next are kind of our cakes, our cookies, our pies. Then lemonade and fruit punch, all right? Sugars and candy, ice cream, frozen yogurt, ready-to-eat cereals, and if you keep going here, you would find salad dressings, ketchup, other condiments. There are added sugars in many different products. So if you just take a quick look, even in some of our frozen foods, take a quick look and just learn to be a little savvier about labels when you see sugars. And now you know a few more terms, right? Dextrose, molasses, cane sugar, high fructose corn syrup. These are all sweeteners and they're all caloric. And so if you're seeing these all over the label, you may want to think twice about the product or find one without these added sugars. And here's another handy list of where you're going to find added sugars. In fruit drinks, you're going to find tons, energy drinks, and so forth. So how much is too much? As I said, and I don't know why this says 2105, it should say 2015. 10% or less of your total daily calories should come from added sugars, right? And, women should have less than men, and we currently consume, more than we need. And 17 teaspoons is about what is in one Coca-Cola, one bottle of Coke. So does sugar lead to obesity? Do sugar-sweetened beverages lead to obesity? And I would posture that, I would wage that yes. I would posit that yes, they do. In my research and all of the literature reviews that I've done, every day Americans consume some form of sugary drink. Most of us do anyway. And we think that the additional calories lead to the excessive weight gain, and we think that sugar in liquid form increases our appetite. But also, I think that it doesn't fill us up a whole bunch, so we can keep drinking it. And a lot of times we drink it mindlessly, right? We just can be sipping on a soda. Think of those 32-ounce big gulp sodas. I mean, someone can sip on that all day and not even realize that they just drank a couple of thousand calories in soda. And this is a handy table of how many sugar-sweetened beverages people drink by sex, and the relative sizes of soft drinks. Look, back in the 50s, I think it was a 4 to 6 ounce serving of Coca-Cola that you would get at McDonald's or when you ate at a restaurant. And that crept up to 8, 12, and now our standard size is a bottle of cola, right? Which is usually over a couple hundred calories. So how can we avoid sugar? I mean, if it's everywhere, how do we avoid it, right? And how can we replace it? So we know that diabetes is growing. Type 1 diabetes is also a condition in which we need to be mindful of diet. Type 2 diabetes is more prevalent than most. And then there's prediabetes, right? Which is a precursor, it can be a precursor to type 2 diabetes that really does stem from the same type of dietary patterns. And this is a diagram of the different types of diabetes. Type 1 diabetes is an autoimmune disease, so it is less impacted by diet, but still those with it need to be mindful of diet. Why is it a growing epidemic? Because more people are eating more and more sugar, because our products contain more and more refined sugar. And here's the list of problems that some of which we discussed earlier: kidney damage, ketoacidosis, which is a dangerous imbalance of acid base in the blood, which can be deadly. This is just part of diabetes. Again, you can have very low blood sugar or very high blood sugar, both dangerous. Just in brief, glycemic index ranks foods in order from the highest impact on blood glucose to the lowest impact. Believe it or not, and this is not to say you shouldn't eat carrots, but carrots have a very high glycemic index, okay? Whereas, say, broccoli would have a much lower, right? And that's basically because the sugars, the natural sugars in carrots are more condensed and sweeter than those in broccoli. GI, it really comes into play when we're thinking about, say, white bread versus, whole wheat bread, or, eating too many carbohydrates versus not enough protein, okay? But just remember that the glycemic index ranks foods according to how much they elevate blood sugar. Sugar substitutes. Now, we have to be careful here. We don't want to go overboard. There's been a lot of study on sugar substitutes and whether they increase appetite or decrease appetite, or what their effects are on the body. Are they cancerous or not? These need to be approved by the FDA, and there's constant surveillance going on as to their health ramifications. Okay, some are sweeter than sugar, but contain fewer calories. Okay, and so that is one benefit that we have from sugar substitutes. Here's some foods that they've been used in, candies, candy bars, we know like frozen yogurt, can contain those, and other drinks and all of this stuff, cookies and so forth. Some that you might hear that are reduced calorie or sweeteners that are reduced in calories, polyols, which are sugar alcohols, and sometimes these can cause diarrhea and other problems as well. And the reason for that is they aren't completely absorbed, right? They're usually labeled as sugar-free. Things like polyol, sorbitol, mannitol, xylitol. Tagalose is another one that's not quite as sweet as table sugar, but it can be used. Saccharin, we know, has been scrutinized as potentially cancer-causing, but those studies were done mainly on animals. Aspartame, the same thing, although people with phenylalanine ketonurinary disease need to be very careful of this because they do not have the enzyme to break this down. There's one called neotame. And, there's a number of other ones. Sucralose is Splenda. It's much sweeter than sugar. The body doesn't absorb it. And then we have other things like stevia, which she doesn't, let's see if she lists here, is derived from a plant in South America. It's much sweeter than sugar, and that has not been well studied, although because it comes directly from a plant and it's unaltered, people tend to think that it's more healthful. But the research is still out on that, okay? Again, we know fiber is super important. It has a lot of preventive effects on constipation, diverticulitis and diverticulosis, which are caused by, the weakening of your intestinal lines and bulging out because there is not enough fiber in the diet. It can help prevent obesity because it fills this up, and it can prevent heart disease again because it can pull cholesterol out of the body. It can help with colorectal cancer because it can help keep the bowels regular and not have toxic materials, right, or acidic materials, right, waste materials against our intestines. And it can help prevent diabetes as well. But again, too much fiber too fast can cause discomfort. And here are just some the viscous fibers that we talked about that pull cholesterol out of our body. They absorb water, and this is soluble fiber. Okay, soluble. Apples, barley, legumes, citrus, and oats. And then these insoluble fibers, they call them fermentable because they are fermented in the colon. Fruit, legumes, vegetables, and whole grains contain these fibers. And again, we know why it's so important. Here's a handy diagram of diverticulitis and diverticulosis. You can see these bulges in the intestine, which are mainly caused by not getting enough fiber. They're weakening of the intestine. So to make over your diet, if you can choose higher fiber cereals and foods over more refined ones, you can go a long way to increasing your fiber and then your health. Oatmeal or bran flakes over corn flakes, whole grain crackers instead of just regular crackers, and whole grain breads, popcorn instead of pretzels, and so on. And that is the end of this lesson, students. I hope that you have a better understanding of carbohydrates, and I look forward to talking to you about the other macronutrients. Take care.